All right. So the two important ones that we're going to learn, this lesson in the book is called multiple angle and product to sum identities. Basically, we are going to concentrate on the double angle formulas and the half angle formulas. They are on the blue sheet on the side with all the identities towards the bottom. Do you see where it says double angle relations and half angle relations? Okay. Those are the ones we're going to concentrate on today. And we'll get as far as we can towards finishing 7A and 7B. And 7B is actually part of the homework check, okay? So we'll see how far we can get. All right. The first ones we want to talk about are the double angle identities. There are three of them. There's the sine of 2 theta. That has only one trade you can make for it. The sine of 2 theta is equivalent to 2 times the sine times the cosine. This is the most important one that you need to memorize for calculus. Ms. Gupta would love it if I said you can't use this sheet. You need to know these, okay? I'm not going to do that to you. But that's the one you need to memorize. It's not that hard. Sine of 2 theta is 2 times sine times cosine. All right, cosine of 2 theta will be a little trickier to memorize because there's 3 different ones you can trade it for, okay? I will tell you that if we're calculating it out with numbers, this first one is probably the easiest because it'll give you a common denominator. But sometimes when we're solving equations, like if we want to get rid of all the cosines, you might use this one. Want to get rid of, make it all into cosines, might use this one. So we'll look at that later. Tangent of 2 theta has a formula that doesn't seem too bad. It's a little miserable looking, 2 tan over 1 minus tan squared. But you got to remember, guys, tangent is always just sine over cosine. So if we already found a value for the sine of 2 theta and I found a value for the cosine of 2 theta, we can always just take those values and divide them and you'll get the tangent of 2 theta, okay? That's going to be the easier way to do those in a minute. All right, this is a super quick example that's already done for you. I don't know, do we need to turn the light off so you can see a little better? Someone wants to hit the switch by the phone, but it says here, this is negative, it's hard to see. But if the sine is negative 7/25, so opposite over hypotenuse, and it's in the third quadrant. Everybody gets why I'm saying third quadrant between pi and 3 pi over 2. We do Pythagorean theorem and we get it 24 here, and because it went to the left, it's negative 24. So then what we're going to do is we're going to calculate the sine of 2 theta by plugging in the values. It's 2 times the sine times the cosine. So it's 2 times this, which came from the picture, and it comes out a lovely 336 over 625. All right, the cosine of 2 theta, there's 3 trades we can choose to do. They did 2 times the cosine squared minus 1. If you type all this mess in your calculator and do math, enter, enter, you get 527 over 625. Now, there's 2 ways to get the tangent. One way is to use the formula off the sheet, okay? 2 times 7/24 all divided by 1 minus 7/24 squared, blah, 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 blah. The other way is to take the sine and put it over the cosine. If we have 336 over 625 for the sine of 2 theta, and the cosine of 2 theta was 527 over 625, how do you divide fractions? You get 336 over 625 times 625 over 527. Gone, 336 over 527. Now, that was faster to me than calculating all these crazy values, okay? Again, it's really just the numerator here, numerator here. All right. This is what it looks like on your sheet. This is an easy question we're going to start with because all it wants you to do is find sine of 2 theta. What quadrant would I draw this in? First quadrant. How do I label my triangle if the sine is 1/4? Opposite over hypotenuse. Everybody okay? What's the cosine of this triangle then? That's the trick that you got to know and get right, or you're pretty much screwed from there on. Okay, 1 squared plus x squared equals 4 squared would be 16 minus 1 is 15, square root of 15. Everybody can do Pythagorean theorem and get it right? So the cosine is the square root of 15 over 4 because it's adjacent over hypotenuse. So to find the sine of 2 theta, which is the only thing this one asked for, you do 2 times the sine times the cosine. You plug those values in. The sine was 1/4. The cosine was square root of 15 over 4. You multiply, the 2 is on top, right? When it's a plain old 2, it's 2 over 1. So 2 times 1 times square root of 15. On the bottom, 1 times 4 times 4. And then the 2 and the 16 reduce. Everybody okay? That one doesn't seem too bad. Okay, we're going to do the same thing, and we're going to find all 3 of them this time, given this information. A little bit smaller numbers. If the tangent is 4/3 and it's between pi or 180 and 3 pi over 2 or 270, which quadrant am I in? Okay, third quadrant. Draw my little triangle. Opposite and adjacent. What's wrong with what I wrote, though? Yes, I went left and down, so they are both negative. Does that make the tangent positive, though? Okay. Hypotenuse, always positive. This one is a nice -3 squared is 9, -4 squared is 16, 9 plus 16 is 25, squared is 25 is 5. Okay. What I like to do when I do these, guys, is just write down sine, cosine, and tangent, because you're going to need those values for all of this. So if you just list them somewhere, you don't have to keep trying to think about them. What's the sine of this triangle? Okay, what is the cosine of this triangle? And the tangent they gave us was 4/3, right? Okay, we're going to plug those values in to the formulas for these 3 things up here. The first one is the sine of 2 theta. Sine of 2 theta is 2 times the sine times the cosine. If I trade those out for values we just found, I would have 2 times -4/5 times -3/5. You can use your calculator. Yep, you get -4, -3 is 12, times that 2 is 24, 25 times, or 5 times 5 is 25. Okay, so the sine of 2 theta, or 2 times the angle that took us to here, twice that angle would have a sine of 24/25. All right, the cosine of 2 theta, there's 3 trades to pick from, right? I'm going to pick the first one. Is it cosine squared minus sine squared? Because that'll give me a common denominator. The cosine is -3/5. I'm going to square the top and the bottom. Minus the sine is -4/5. Going to square the top and the bottom. So I get 9/25 minus, it becomes positive 16/25 when I square it. So I get -7/25. And that's the cosine of 2 theta. Now, before I do tangent, I want to pause for just a second. If we had an angle that was in the third quadrant, somewhere between 180 and 270, and we doubled its size, it would now be somewhere between 360 and 540. What quadrant would that be in? First quadrant. Something's wrong. I'm not explaining something well. Actually, where's 540? Could be in quadrant 1 or 2, right? 540 is 180. All right, we don't have to worry. We can figure it out. What quadrant is it in if the sine is positive and the cosine is negative? Quadrant 2. Okay. So we have to be, when we've doubled this angle, it's taken us, oh, that's supposed to have a 2. Can't see it very well. It's taken us around all the way back into quadrant 2 somewhere. All right, moving on to the last one. I'm going to show you the long way and the short way. I'm only going to do the long way once, in my opinion. We shouldn't use this very often. What's the formula say on the sheet for 2 theta? Like that? Okay. So it's 2, that would be 2 times the tangent was 4/3, all divided by 1 minus 4/3 squared. Okay. If I type 2 times 4 divided by 3 up here, I get 8/3. Down here, if I type 1 minus parenthesis 4 divided by 3 parenthesis squared, math, enter, enter. Let's see, this would be 9/9 minus 16/9 would be negative 7/9, I think. And then you could do this divided by this, or this times the reciprocal. Something's wrong. 9/9 minus 16/9 is negative. Oh, there we go. It's 24 over negative 7. Okay. The shorter way, remember what I said the shorter way was? What's tangent always equal to? Sine over cosine. So if we had 24 25ths divided by negative 7 25ths, don't we get 24 over negative 7? Would have been much easier, right, than doing this squaring business. All right, so that's the shorter way in my opinion. Not a lot of fun, but it's just plugging numbers in, right? Okay. This is an example using a trade for this. This is a really good example that could be a quiz question, but I don't think you have this, so if you want to write it down, you can. It may be even a homework question, but it says the sine of 2 theta minus the sine of theta equals 0. You have to do a trade for the sine of 2 theta. Sine of 2 theta is 2 times the sine times the cosine, and then back here it said minus the sine. Then you can take out a sine. Does that make sense? You factor out a sine. It'll say 2 cosine minus 1. And then either the sine is 0 or that is 0, which would make the cosine 1/2 and the sine 0. Now, I'm not fond of their answers. Anybody see why I have an issue? Look up here. Does that not look like 2 square brackets to you? No. So if this is true at 0 and pi, it should also, in my opinion, be true at 2 pi. Right? The sine is 0 those places. The book, yeah. The book also, in the book questions, it has square brackets and they don't include 2 pi if you look in the back of the book. I don't know, they just type it wrong, I guess. Cosine is 1/2 at pi over 3 and 5 pi over 3. So all of these, plus, in my opinion, 2 pi, if they're going to put a square bracket, should be the answers. All right. The next kind of trades we're going to talk about are called the power reducing identities. There's only 2 of them listed on your blue sheet. The tangent one isn't on your blue sheet. We rarely use these, but do you see them on the far left lower corner? Okay, they're the ones with the squareds. Okay. Do you see where the tangent one comes from? Look up here. If you put the sine over the cosine, you'd get this tangent mess, right? You just put this mess over this mess and you'd get that. we're not going to hardly ever use these. All right. We are going to use a trade to solve this. Do you have this question? No? Okay. So just help me. We're going to leave the cosine squared, but I need a trade for this. How many options do I have? I have 3 different options. Which one do you think you might want to try here? What is the second one? Why would you pick that one? Because the rest of the question already had a cosine squared, right? So that seemed like a good plan. Now, what happens if I distribute? If I could write. What do you want to do next? If I combine those, I get a -1 cosine squared. You want to subtract the 1 over to this side? Okay, now what? Divide by the -1 and I have cosine 1 cosine squared equals 1/2. Square root causes it to be positive and negative. Square root of 1 is 1. Square root of 2 is square root of 2, which is... Okay. Where's that true? Pi over 4, 5 pi over 4, 3 pi over 4, 7 pi over 4, because it's positive or negative, yes? All right. So that's equation solving where you would use a trade. Because it was cosine 2x, we had 3 to pick from, so we have to be a little bit careful and think ahead what we're trying to get rid of. All right. These are the half angle identities. Can you look on your blue sheet, guys? They're all listed on the blue sheet, all 5 of them on the far lower right-hand corner. Did you find them? Okay. I forgot to put them on the white notes sheet, but it really doesn't matter if they're on the blue one already for you, right? Okay. I don't know why they're not on the white one, but they're not. It does say here, if you were doing an identity proof or something, you might pick this one because look, it has an easier, if it asks for a trade for tangent, because this has a single denominator rather than a expression in the denominator. But most of the time, the issue with these kind of questions is going to be this. Do you see this plus or minus? You have to decide, is it plus or is it minus? If you just decide and leave it plus or minus, you won't get full credit. You don't make a decision and you leave it plus or minus. Okay, I want to explain what's going on. These are half angle formulas. So if we have an angle in quadrant 1, its measure is somewhere between what? If theta is in quadrant 1, it measures between 0 and 90. If I want to talk about theta over 2, its measure would be between what? Can you divide those both by 2? 0.45, right? When you cut it in half. Still in quadrant 1, yes? Okay, help me out here, guys. Quadrant 2 angle, theta is somewhere between 90 and 180. Okay, so theta over 2 becomes between 45 and 90. Be careful, where's 45 and 90? Still in quadrant 1. Quadrant 3 angle, theta quadrant 3 would be 180 to 270. Cut that in half. 90 to 135. Be careful. 90 to 135. Still in quadrant 2. Okay, backed up to quadrant 2. If you started in quadrant 4, theta would be between 270 and 360. So theta over 2 is 135 to 180. Be careful. Still in quadrant 2. All right, this is what you're going to need to think about when you do these, because you don't have to memorize this. You can logic it out. because then it's going to depend what quadrant you wind up in after you divide, okay? Whether it's the sine, cosine, or tangent is positive or negative. Okay, so we're going to try this question. I don't like these. I've already told you this yesterday, because they're ridiculously ugly answers, and you can just type sine of 22.5 on your calculator and get an accurate answer to 15 places or something stupid, okay? It is a Common Core standard. I'm going to show you how to do them. I'm not going to put one on a test or quiz. So try this because it's good practice with fractions. Oh, humor me. And okay, 22.5 is exactly half of what, guys? So we're going to write this as 45 over 2. And then we're going to trade it for a half angle formula. Can you tell me what the half angle for sine is? 1 minus the cosine of 45 over 2. Okay? So the sine of 45 over 2 is equal to plus or minus the square root of 1 minus the cosine of 45 all over 2. Just traded right off our sheet. All right, now we're going to flip our sheet over. Well, is it plus or minus? 45 divided by 2 is 22.5, which is quadrant 1. And everything in quadrant 1 is positive. So this is going to be a big fat plus. Then when we put the cosine of 45 in, we get square root of 2 over 2. Okay, now do you want to cry a little bit? Okay. This is not that bad because it's not going to simplify. It's just going to be a big mess, okay? Do you remember, I keep harping on this, when we have things like this, and we have complex fractions, we can multiply through by the common denominator and get rid of all the fractions, yes? Or get it down to a simple fraction. We're going to do the same thing here. We're going to multiply the top and bottom by the only denominator, which is 2. Okay, if I distribute a 2 to the top, 2 times 1 is 2. 2 times the square root of 2 divided by 2 will just be square root of 2. The denominator, though, 2 times 2 is 4. That was all under a radical. And it stays under a radical on the top with 2 radicals. I know that's the only way you can write that as an exact answer, and somehow that's legal. Okay? I know, it doesn't look like it should be. Square root of 2 minus the square root of 2. All over the square root of 4 is just 2, so at least we got rid of that. Now, guys, if I had gone over here and gotten a common denominator, that 1 would have been 2 over 2. You would have had 2 minus the square root of 2 over 2 times a half, which is the same thing. I promise it works. I'm just trying to do it the shortest way. Because this radical was over the whole thing, so it's really okay. That's why the radical doesn't go down to the bottom anymore, because I simplified square root of 4. All right, we're going to try it one more time. Anybody know what this is half of? It is a half again. 11 pi over 12 is half of 11 pi over 6. So the cosine of a half of 11 pi over 6. What's the cosine? I know, we're only going to do one more and we're going to quit. What does the cosine half formula say? Plus or minus 1 plus the cosine? I did the last one right. I had a minus, right? Okay. Earlier today I messed up and started switching things around. Okay. This is going to be 11 pi over 6 in here too. All right. Let's think about the quadrant for a minute. Can you change 11 pi over 6 to degrees? Well, or 11 pi over, well, 11 pi over 6 is 330. Half of that would be half of 330. 165, which is quadrant 2. Okay, when we cut this in half, or 11 pi over 12 is almost pi. 11/12 of a pie, right? It's almost a whole pie. Someone took a little piece of your pie. Okay, so you're in quadrant 2. Is the cosine positive or negative in quadrant 2? Cosine x is negative. So we're going to get negative square root of 1 plus. I need the cosine at 11 pi over 6. Ugh. So I have 1 plus square root of 3 over 2 divided by 2. Can we do my little magic trick? What do we want to multiply top and bottom by? What does the top become? Square root of 3, right? 2 plus the square root of 3 over 4. It's half of 11 pi over 6 is 11 pi over 12. We were supposed to calculate this, and we need to use either a half angle or a double angle formula. So I said this is equivalent to half of 11 pi over 6, which is 11 pi over 6 divided by 2, because it says theta over 2 is the way it's written on here, theta over 2, okay? Back here, we plug the values in, get this, we still have a big square root, so it simplifies down to what, guys? Okay, disgusting. What did I say already, guys? Am I going to make you do one of these? Okay. Yes. Nope. You are absolutely right. Thank you. Thank you. Thank you. Yeah, it just disappeared because it's disgusting. Yes. I was trying to clean it up a little bit. All right, guys. This is another trade problem, and it's probably more complicated than I would give you, but if you had cosine of x over 2, that would trade for this, yes? There was a squared on that. When you square all that mess, all it does is get rid of the radical. Now, you got rid of the radical, so you have a 2 that was out in front of this. 2 times that 2 down there would divide out. Then you get to here. This is something I would ask you to do. If I asked you sine squared equals 1 plus cosine, what could you trade? Sine squared is 1 minus cosine squared. So you'd have 1 minus cosine squared equals 1 plus cosine. If I subtract a 1 from each side, I'm actually going to add this over here. Remember, you can't divide that by cosine because you lose some of the solutions. Do you remember that? Okay. Now you can take out a cosine. Cosine x plus 1. And you have, where's the cosine 0 or the cosine negative 1? This happens at pi over 2 and 3 pi over 2. The cosine is negative 1 at pi. Okay. Talked you through that one a little bit. Again, this is actually an easier problem. I don't know. I think you have this one. There's a sine to theta. What's the rule for that one, guys? Cosine equals 2 times sine times cosine. Okay, now we can make this complicated, or we could try to simplify. It's got a cosine squared, etc. But what I have right now is a whole bunch of things that multiply to make 0. I'm just making something up over here. If I have a whole bunch of things that multiply to make 0, don't I already know how to solve this? Right? So what we did when we had that kind of problem? So over here, we can say cosine equals 0. I guess we could say 2 equals 0. That doesn't sound good. We could say the sine theta is 0. Cosine theta is 0. I don't think we need to say it twice, do we? Okay, so where's the cosine 0 or the sine 0? Yep, all the quadrantal angles. So 0, pi over 2, pi, 3 pi over 2, and you can list them in any order you want. This one does have a parenthesis, so I won't include 2 pi. That wasn't so bad, was it? All right, we're on the back. All right, what quadrant is this talking about? It says pi is less than an angle is less than 3 pi over 2. So it's in quadrant 3 between 180 and 270. So draw yourself a little picture, label the sine -3/5, and then tell me what the cosine and the tangent would be. Opposite hypotenuse. What do I get for adjacent when I do Pythagorean theorem? Okay, so the cosine is, and the tangent, if I wanted to use it, would be opposite over adjacent 3/4. Everybody okay? I always write those down because then I don't have to keep looking at the picture and recalculating them. All right, we are going to calculate these 6 things. It's so exciting. Okay, sine of 2 theta. What's the trade? 2 sine cosine, okay? But instead of theta, I'm going to use alpha, and I'm going to use the values from over here. So it's going to say 2 times -3/5 times -4/5, which is, you can use your calculator. 2 parenthesis -3 divided by 5 parenthesis -4 divided by 5 parenthesis math, enter, enter. It will work. Okay, cosine 2 theta. I'm going to go with cosine squared minus sine squared. What are the values I'm plugging in? Okay, I square -4/5 and I get 16/25. I square -3/5 and I get 9/25. I subtract and I get 7/25. Can I do the tangent really super easy? 24/25 is being divided by 7/25, which is 24/25 times 25 over 7, which is just, yes, exactly. As long as these are all the same, 2 thetas or half thetas or anything, you can just do sine over cosine. All right, now the fun begins. We got to use the half angle formulas. This one is plus or minus the square root of 1 minus cosine. Okay, let's decide this plus or minus jazz. Currently, we are in quadrant 3, somewhere between 180 and 270, yes? If I cut that in half, because the next 3 questions say over 2, I get 90 to 135. What quadrant would that be? Quadrant 2. In quadrant 2, the sine is going to be positive. The cosine is going to be negative, which is going to make the tangent negative. Okay. Got that taken care of. All right, now we're going to put the values in here. So it is square root of 1 minus, what's their cosine? What's wrong? Oh, yeah. Minus a negative will be plus. Yep, good job. Okay. So I have 1 plus 4/5 all divided by 2. Use your calculator if you want. 5/5 plus 4/5 is 9/5. Dividing by 2 is the same as times a half. 9/5 times a half is 9/10. Did you get it on your calculator or not? Anybody having trouble? Yeah, I'm not going to forget the root, but we don't type that in, right? Because that's to keep it exact, we got to not type that in. All right, square root of 9 is 3 over the square root of 10, which is, okay. All right, what's the formula for this one? Same but plus, isn't it? 1 plus cosine theta or alpha over 2. So I'm not going to lose my negative out front this time. 1 plus negative 4/5 over 2. The outside one, yes. This becomes 5/5 minus 4/5 is 1/5. Half of that would be 1/10. Is anybody using their calculator and not getting it to work out? Okay, square root of 1 is 1, square root of 10 is 10, so we get what? Oh yes, I lost my negative along the way. Okay. There's a really long, complicated way we can do this, or there's put the sine over the cosine. Now, the sine was 3 blah, 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 blahs. The cosine was -1 blah, 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 blah. So if we divide out the blah, 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 blahs, what's left? 3 over -1, which sounds a lot like, okay, if you want me to write it out, it's 3 square roots of 10 over 10. We got to flip this one over, so it's 10 over negative square root of 10. This cancels. I have a 3 and a -1. I get -3. We good? I did sine over cosine. You good or not? No? Claire, here? This was the sine, this is the cosine. All that square root of 10 over 10 is going to divide out. So we just end up with 3 over -1. Make sense now? Okay. There is another way to calculate it. You can use the trade that's on the sheet, but. All right. Yes, there's a typo here. You got to fix this on your sheet, okay? Yeah, I don't know how to for happy face. It's supposed to be an X. Can you make that an X, please? So now I need you to look at your blue sheet. Where is something that says sine times cosine plus cosine times sine from yesterday? Sine cosine plus cosine sine is sine A plus B. Only what am I writing instead of A and B? I over 2 plus X. Now, there's actually 2 possible solutions to this, because if you had instead traded out the sine at 90 to be 1 and this cosine to be 0, you would have got 1 times the cosine, which actually is equivalent to this. I would have taken either one of these 2 answers. Now, back here, find this guy. We just learned it today. Cosine squared minus sine squared is trade for cosine of 2 something, only my something is a goofy beta looking thing. That's it. Pretty easy. Where's this one? Tan minus tan over 1 plus tan tan. A minus B. So we're going to write alpha minus beta. Okay, what about this one? 2 sine cosine. It's sine of 2 something, but our something is actually 3x, so we could simplify that to sine of 6x. A few more of these. Well, that's a nasty looking mess, but we have a trade for that. Plus in the middle makes it cosine, something over 2, but our something instead of a theta is a 4 alpha. Well, that will simplify down to a 2 alpha. This one's a little tricky, not really. Sine, cosine minus cosine sine. Sine, cosine. Sine of A minus B, which is 30 degrees minus 40 degrees, which is sine of negative 10 degrees. What can you do with a sine and a negative? Yes, it's an odd function, so it goes out front. Negative sine of 10 degrees. Cosine, cosine, plus sine, sine. Depends what the directions are. The directions on the quiz say simplify, do not evaluate. If it was cosine, cosine plus sine, sine, it becomes minus. But can you simplify that, please? What is 1/3 minus 1/4? 1/3 minus 1/4 is 1/12, right? Use your calculator, just leave off the pi, right? All right, I'm going to do one of these. Actually, I'm going to do one of the ugly ones. Let's do B. Because when you expand this, use your sheet. Sine A plus B becomes sine of 60 times cosine of theta plus cosine of 60 times sine of theta. Is the sine of 60 anything nice? Square root of 3 over 2 times the cosine of theta. Is that right? Okay, sine is square root of 3 over 2 plus 1/2. Okay, we can't simplify that. It's just an ugly, icky mess, okay? This first one simplifies nicer because at pi over 2, you get zeros and ones, okay? But that's all you're doing on these. Does that seem okay? You can finish those. I left you a grand total of 2 questions. You can't do 2